2023 Chevy Bolt, and you could see the air conditioning line here, and you see where the, oh, what is that? The high side goes into the suction side, so that's your internal heat exchanger right there, and that's why you see that the line is so much bigger than the actual size of the line itself, because hot liquid refrigerant is traveling on the outside of that smaller suction line that is cold, so you could get more superheat, subcooling. Always reverse the stuff. And you can see over there the other fitting where it comes out. If you could see down below right there, you could see the high side liquid line where it comes out right there, and it goes towards the expansion valve into the dash right there. Okay, right there. So that's where it comes out. Now on this one we have a second circuit on there. Not only are we cooling the passenger, but here's a plate heat exchanger. That little guy right there, that's a plate heat exchanger. And if you look above it, right there is an expansion valve, and then that's just the block right there. There's your service port and your lines in and out. And if you look there, if you're used to see that right there, there's your plug on the bottom of your H-style expansion valve. So there's refrigerant actually flowing through this. Go on Google and look up plate heat exchanger and look at construction of plate heat exchanger. You might Google those search terms so you can see how these are manufactured inside, how every one of those little tiny lines, you see those little layers in there like rings on a tree? So every one of those in between, refrigerant, cold refrigerant is traveling in one direction. But then hot coolant comes down, and on the next line, hot refrigerant is going in the other, and it's getting cooled by the refrigerant, and then it comes out cooled going out the other direction. So it's exchanging the heat. The refrigerant is absorbing the heat from the hot coolant, cooling it down so it can recirculate and go back into the system. That's how this is working. Now if we follow this, it's coming back from, say, the battery, going in the back, cooling down the battery. We're going to say that's where that one goes because I see it's going in the back. Here's the part number for you guys who actually want to look up a part number and learn more about it. Right there. Let me get really close for you guys. There you go. For those of you like minds who want to know, there you go. So this coolant gets cooled because it removed the heat from the battery. When you're cruising and it's charging the battery going downhill, or whether you're accelerating, or yeah, those are the two main modes. When you use energy or you put energy back into the battery, it develops heat, and you got to get rid of that. So here it comes back out here, it goes into the reservoir. So we go into the reservoir, and if we see off the bottom, we have another pipe. So there it is right here coming off the bottom. You want to always take you'll notice the coolant will always leave at the bottom, because you don't want it to go this way, because if the coolant ever goes down a little bit, it'll suck in air, and when it hits the impeller of a water pump, it'll just turn into foam and it'll stop pumping. So the coolant goes down, and let me see if I can show you the water pump. Right, hold on. Let me get my laser pointer for you guys. Yes, we are. So if you look right there, that is the line coming from above, and it's going right into the center of the electric water pump right there. So that's the center line, and this is the line leaving. That's out of the pump. So the cold water, the chilled water goes down into the electric water pump, and let's see if I could zoom in for you guys. Ooh, that's too much. Yeah, right about there. So it goes right there, it comes in, goes into the electric water pump, and then comes out of the electric water pump. And yes, I am in a real shop banging hammers. So that's how that works right there. And you can look up more of this, because if you've noticed, for you guys who don't get a lot of new cars, plate heat exchangers are on nearly everything now, especially electric. You just can't get away from it. And that's it for this. Oh, you notice one reservoir, two reservoirs, three reservoirs, three completely different isolated cooling system reservoirs. And we just have a condenser up here, and then we have what you would call a radiator, but we got to get rid of that name radiator and call them heat exchangers. And you can see a coolant line coming in here in the back right here, and somewhere else there's another one, but we only have 2 cores here. And that is it on this 2023 Chevy Bolt. And then over here we got a Honda. I'm not sure which model Honda this is. We have a new Honda over here. There's our compressor, our AC Delco GM compressor, but probably, I think it's not manufactured by them, but manufactured for them. And it's actually this one. Oh, why can't I remember who makes this? I don't see any other sticker, but I'm trying to remember whose part number that is for the oil. RB100. Okay, I'm having an Alzheimer's moment right now. But anybody can look up that compressor number and those parts numbers and find out more of this. You go to the manufacturer's website and go look for the white papers, look for the specification papers, and you can learn about the operation of this specific compressor. You can learn that there might be a oil drain hole right there. You see that bolt right there? So you got that bolt right there. And if you look that up on the manufacturer's website, that is where you're going to be balancing out the oil, right there. You don't balance out the oil by draining oil out of the ports, the high and low side port. You open up that drain hole right there, and there's a cavity filled with oil here, because you won't get it all out by draining right here. You want to find out what's inside the compressor. Not all compressors have an oil drain hole, and not all guys even know there's oil drain holes, and they try to balance by just pouring out oil because they were taught by an old guy, and an old guy from the old school, you always used to just do the ports. And really old guys who should have known better, that really old compressors had a sump pump. They had an oil drain pole like the York, the Tecumseh, the Axios A6, the Chrysler V2. They all had oil sump pumps that had roughly 6 ounces of oil they stored in the bottom of the body of the compressor. Here is our compressor control valve. This is what controls the displacement of the compressor by pushing on the swash plate and changing the displacement inside to change the displacement, the compressor control valve. And as you can see, the radiator would be here, the fans would be here. This is not easy to get to. This is not a friendly one. Here's the ground screw. If you look right here going into the coil, real carefully right there, you only see 2 wires, and they're going into the clutch. That is your electric field coil. That's your inductive coil that makes a magnet. And basically on this one right here, its power goes in, and then another second little wire comes out, and it just grounds to chassis. So there's your 12-volt coil, just like a light bulb would be, but more like electromagnet. Somebody doesn't like me using the term light bulb. He goes, it's inductive. Okay, yes, it is, but that scares people when I use a fancy word like inductive. They go, what's inductive? Okay, think of a light bulb. But we were all in 3rd grade, and we had a science teacher or the teacher get a 6-volt battery, get a big nail or bolt, and they curled a whole bunch of coils of wire around a bolt, and they touched it to the positive and negative of the 6-volt battery, and they made an electromagnet. That's how simple that is. That's all it is. And that's it on this one for its little thing. All right, guys, I'll see you later.